In this episode of the Ari Kim podcast, I'm joined by Marcin Kaźmierczak, co-founder of RedStone Oracles. RedStone Oracles provides real-world data to decentralized financial protocols and applications. Using examples and easy-to-understand explanations, Marcin and I discuss how oracles work, how RedStone services are unique compared to other Oracle services like Chainlink, and some of the risks and trade-offs of decentralized Oracle systems. Marcin, thanks so much for joining me on the podcast today.
Hi, everyone. It's a pleasure to be here.
So RedStone Oracles is a very interesting project, and I think oracles overall are interesting. I know they're a little bit more complicated for those who are not too exposed to the blockchain and crypto space. So Marcin, before you even tell us a little bit about yourself and RedStone Oracles, I want to start by just painting a little bit of a picture of what oracles are and what the functionalities of them are. So do you want to give a little bit of a high-level overview of what oracles are and how they work?
Yeah, sure. So again, thanks a lot for hosting me. To start with what an oracle is, blockchains are isolated ecosystems that do not have access to external data from the internet as we know it right now. So for example, Ethereum, Bitcoin, but also other networks such as zk Sync, Arbitrum, and so on, do not have access to information from the real world. Therefore, you should have a kind of like an adapter that shoots that data to this ecosystem so that you can create smart contracts that execute upon that data. And in order to do so, in the history in the past, in 2013, 14, people were building such adapters themselves. But it's a very crucial piece of this flow because if you manage to hack such an adapter, you can hack the whole system because the triggers later hit because of the information that is fed via this adapter. Therefore, specialized companies or startups came into existence called oracles. So the single job of an oracle is to aggregate data from various sources, make sure it's as close to true as possible, and then deliver it to end users so that they can execute a smart contract or create any other logic on top of blockchain.
Got it. So oracles are responsible for bringing information from the real world and then putting it on the blockchain and then interacting with smart contracts.
Correct.
So Marcin, why don't you tell us a little bit about yourself and your role at RedStone Oracles and also explain the evolution of the project. So if you could explain a little bit about the context of how oracles have been primarily dominated by Chainlink and then how RedStone Oracles plans to change that.
Sure. So maybe let's start with myself. So I joined the crypto and blockchain space in late 2017. When I was writing my bachelor's thesis about blockchain technology and the future applications at that time. People were thinking about, maybe in logistics, there are going to be use cases, maybe in healthcare. But here we are in 2023, and we know that the biggest use case right now is DeFi and basically like financial applications. Over the course of these years, I was following the news. I was also working in a startup that went bust and I didn't get free salaries. That was in 2018. So that was a pretty harsh start. After that, I was traveling around the world. I lived in Porto, Portugal, and Taipei in Taiwan. Ended up coming back to Warsaw and working at Google Cloud. And in 2020, in December, together with my co-founder, Jacob, he came up with an idea, hey, let's create an oracle that is more scalable and can deliver more horizontal scaled data feeds, not only like blue chip tokens. And I was like, yeah, sure, let's give it a try. I know that it's a pretty monopolized sector. And that's how we started RedStone, right? And fast forward to today, it's not anymore only Chainlink like delivering the data feeds. Naturally, it's the biggest player that did a lot of good to the market. Thanks to Chainlink, we also managed to have early days of DeFi and the whole DeFi summer. But the way they introduced, the way of delivering data they introduced in 2017, 18 got a bit obsolete and is not that innovative anymore. Therefore, there's for sure room for innovation. And how we do our magic, I'm going to tell you a bit more later. But just to put it in a nutshell, our design was created at the early days of 2021 with the Omni ecosystem world already. So layer 1s, layer 2s, and with more flexibility regarding the data types that you can deliver. So not only like popular tokens, but also real world assets and other types of data.
Great. And let's walk through an example of how an oracle is actually used in practice, say for a DeFi protocol. So you want to walk us through how, let's say, using information like a price might be brought on chain. At least we can start on this point from a very high level.
All right. So let's take one of the biggest protocols out there right now, which is Aave, which is a lending protocol. People come to Aave to lock their crypto assets and borrow against it because they believe it's going to grow. The collateral they lock is going to either stay with value or grow over time. So let's take the simplest example right now. Imagine you have Ether and you go to Aave on Ethereum. You have one Ether, which is worth, let's say for simplicity, $2,000. You lock that Ether and then you borrow against that, for example, USDC, and you want to borrow, let's say $200. And with this $200, you can go buy ice creams, like a lot of ice creams. And then Ether appreciates in value over time. And you come back to the loan that you did after half a year. And you take out the loan with paying back the $200. But the Ether you took out after half a year, because Ether appreciated, might be worth more than you started with, right? So this is the simple way how users might interact with Aave. And in order for Aave to know how the price of Ether changes, it has to use an oracle. Because, okay, it could pull that price from an API of a price aggregator such as CoinGecko or CoinMarketCap, but these services have downtimes. And for smart contract, even like milliseconds of downtime can be like truly disastrous. And second thing is blockchains are like set of nodes. So it's not so trivial to use APIs. Usually you need to have like a dedicated infrastructure that is adjusted for smart contracts. Therefore, over this course of 6 months, as I told you, Aave protocol would fetch the price feed from the oracle and then report it as it is.
Great. And this is done in a decentralized process compared to a centralized process. So do you want to explain why oracles, I guess let's explore actually the arguments both for and against these oracles being decentralized. So firstly, I'll ask you, what is the trade-off for having an oracle being decentralized versus centralized?
Of course, I suppose one thing that people many times forget about decentralization as a principle, and I want to put a lot of emphasis on that, is decentralization is costly. So in order to have a decentralized system, you have to have the justification of this cost. In DeFi, it makes sense because we are talking about a huge value. We talk about trust and so on. In many of the other sectors I told you about that people thought that blockchain would have a huge implementation in the future, the cost of decentralization was just not justified. I mean, these systems could work, but centralized are just more efficient, and the cost of decentralization is not explained by the value that would be received. And in regards to oracles itself, in a decentralized system, you are way slower to react to crises and unusual situations, because usually when you have a centralized system, then you have a person or an entity that is responsible for that. So when something bad happens, that person or the entity should react, should do some mitigation strategy, or pause or try to fix a bug or whatever. In decentralized systems, it's not so easy. And we are still in early days. So if you have an oracle that is fully decentralized as it is right now, one, it's harder to probably react to crisis situations. And two, it's probably harder to innovate as well, because decentralized systems are way tougher to keep on expanding and like making more complicated. It's rather good for a system as it is, right?
So what would be an example of a crisis that can make it challenging for a decentralized system to respond to based on some of the occurrences within the crypto space so far?
Okay, so talking about real world examples, even this year, like the DPEG of USDC, like in some cases, it was important that protocols took measures. So now I'm talking about decentralization of a protocol. So a centralized protocol probably could react quicker to the DPEG of USDC and also get prepared in case USDC had been to fall even lower, right? Because we've seen the DPEG to, I don't remember exactly, like 93 cents or maybe 89 cents. But there was a word that USDC kept depegging even lower. And then, there has to be a mitigation strategy. In regards to the oracles, there was the whole Luna crash, Terra Luna, that made a lot of tokens that were used as collateral almost disappear, like Terra and UST at that time was used in many cases as a collateral. So, for example, how Chainlink approached that topic was at a certain point when UST was depegging, going lower and lower to zero, almost zero. At a certain point, Chainlink just stopped delivering the price lead, which caused a lot of problems for many protocols. For example, Venus protocol on BNB lost, as far as I remember, $11 million because the Oracle stopped reporting the price. And now it's not a trivial question whether it should be stopped or kept reporting as is, and then try to mitigate that in another way. But if you have a decentralized system, that decision whether to stop or not would have to be brought to probably a governance or any other process rather than a single person or some people within the company hitting stop and then it is not delivered anymore.
Yeah, and I want to add on to that by explaining that this USDC stablecoin unpeg situation, USDC is intended to basically be a representation of a US dollar. So it's supposed to be like a 1-to-1. And then it's problematic when it depegs because the idea is for every $1 is stored, and then you're not really supposed to have these depegs, and it creates issues within the crypto market. And then in the case of Luna, this was an algorithmic stablecoin, same idea. It's supposed to be pegged to the US dollar, and then we saw it essentially go to zero. So again, one of the trade-offs here is that when we have these decentralized systems, well, if something goes wrong, it's really hard to respond to some of the issues that it causes. I want to talk about an important subject, I would say, which is the vast amount of support that RedStone Oracles has had to bring more data effectively on chain or provide a new solution for these new DeFi protocols. So why don't you speak to some of the success that RedStone Oracles have had in terms of exciting people, especially those who are more prominent in the space about this project?
Yeah, so since the origin of RedStone, what we managed is, one, deliver the product that works, which is not that obvious in this space. Like we've seen countless of projects raising millions of dollars and never releasing a working product, just creating an anticipation. We did manage to launch beginning of 2023 fully operational product that right now secures hundreds millions of dollars already on multiple networks. So we've got actively using us 14 serious projects. I'm talking not about like hackathon projects just for fun. I'm talking about serious users that have their users as well. We managed to receive from prominent funds and angel investors almost $8 million. Wow. Some of the VCs that invested in us are Lemnis Cap, Blockchain Capital, Maven 11, Coinbase Ventures. And in May this year, so 2023, we also announced that Stani Kulekov from Aave, Alex Gluchowski from ZK Sync, Sandeep Naival from Polygon, Emin Gunsirer from Avalanche, and a bunch of other top builders also joined our journey as angels because they see the need for more innovative oracles, and they believe we are the right people to disrupt the space. So not only we are good with timing, but we also have all the capabilities and technical skills in order to execute. And we keep on showing that. Since the beginning of this year, the interest in RedStone has skyrocketed. So even today, I'm again very sorry for being late, but truly the amount of messages and requests for demo or explaining how exactly RedStone works is just overwhelming. And we are still a fairly small and nimble team located here in Poland, Warsaw. So again, I'm very grateful for these VCs and angels for the trust, and we keep on doing our job.
Yeah, that's very exciting, and I'm very excited to see the project continue to be onboarded by a lot more projects in the following year. I'd love to jump into some of the now details of how RedStone Oracles actually work. I know we've spoken now about how oracles are very important in the space for bringing data on chain, how decentralized financial protocols, right, that allow people to borrow and lend cryptocurrencies. We've named a few like Aave before, right? This is facilitated through oracles. And we've also explained how there's some trade-offs between decentralized and centralized services. And basically, decentralized services are very expensive and are difficult to change if something happens that's bad. So let's jump into the specifics of RedStone Oracles. What is the very first step for someone who has a DeFi protocol or decentralized application to use these Oracle services?
Yeah, so I would say there are various stages. So let's imagine you're a hacker on a hackathon and you would like to use RedStone. So you're coming from the very scratch. You can just jump into our documentation to understand like how the free dedicated models of data consumption work with RedStone. So again, we have not one, but 3 models because we see there needs to be more tailoring in regards to delivery of data. So in 2023, we don't have any more saying one Oracle fits it all. No, it depends on the use case, how you deliver the data, whether it's important about the frequency or the gas cost of delivering the data. So there are many like variables that you should take in mind. And imagine you want to create a simple lending. So again, a new Aave, but just using RedStone, because currently Aave is using Chainlink. Then you would just go into the documentation. You can take Aave codes, you can try to fork it, and then, integrate as it is, either in the model that is similar to Chainlink, which is called RedStone Classic, which delivers data on chain. So then there is not much innovation. Or the second model that is called RedStone Core, which is also referred to as on-demand Oracle, where the data is not delivered to on-chain storage with intervals as it is with Chainlink. Instead, only when the user of a dApp sends a transaction via the dApp and it goes on-chain, to that user transaction, RedStone attaches signed data packages, and then it ends up being delivered to the destination blockchain and utilized for any action that user wanted to do. In such a flow, we minimize the gas waste and also optimize the whole flow. Why? Because imagine there's no activity from users for, let's say, 30 seconds, and you keep updating the price, then it's just updated because, right? And then imagine alternative world where there is a user hitting a transaction every 0.1 second, so very high frequency transactions. So to each of them is going to be attached another a side data package. So I would say our flow of this on-demand Oracle is more adjusted for usage as it goes, rather than creating a monolithic infrastructure that just stays there and is used whatever. I would maybe create a comparison here with the cloud revolution. In the past, people used to have big servers that were over there in their rooms, and people could use them or not, but they generated cost regardless. And right now in the cloud world, you usually pay as you go, so as much as you actually use, right? Which is way more efficient model. So again, if you're in a hackathon project creator, then you can just go to our documentation and start building. If you're in an established project, so imagine, for example, right now, Gearbox is one of the projects that integrates us, or Sommelier. How they do is they usually created the first version of the protocol either using their own Oracle, because that's also an option, or Chainlink or any other. And then they come to us and discuss and consult how they can utilize our model in their flow that is already running, because it's a bit of a different story when you already have, let's say, a driving car, and then you need to change something as it goes, because usually you cannot just stop it and tell the users, hey, you cannot use it, right? It's just like working on the fly, kind of.
Maybe if you could explain in a little bit more detail how the previous model, or in this case, the classic, is different from the new innovative model that allows information to be stored on the blockchain for the transaction, because I know it can be a little bit difficult to conceptualize. So let's just walk through that point one more time. And if you could really explain why this is really helpful for users and the builders of these protocols.
Of course. Yeah. So now, listen, that's going to be an important one, and I will try to do my best to make it simple. How oracles work nowadays, usually Chainlink or other popular oracles, is they create a smart contract on a blockchain, for example, on Ethereum or Arbitrum or Avalanche or any other ecosystem. And they have a set of nodes that push data in an interval to their smart contract. So let's say every 15 minutes, update the data, usually a price feed of this specific token. And then every 15 minutes, a trigger is hit, and then the price is updated. And with every such an update, you have to cover the gas cost of this update, because on Ethereum and other blockchains, you always have to pay gas. Another trigger that can trigger that update is deviation threshold. So there are two conditions: either, for example, every 15 minutes update, or if within this 15 minutes, the deviation from the previous price is higher than, for example, 0.5%, then update again, because it means that the market is volatile and you have to update more frequently. However, it means you pay more gas, because again, you have to update the contract that is on chain. And then you have this contract that is on chain with the price feeds. And then you have a smart contract of Aave, for example. And a smart contract of Aave, every time that receives a transaction from Aave user, would query that contract of Chainlink quickly for the price, execute the transaction, and everything stays as it is on the blockchain with the two contracts communicating with each other. Or rather, even smart contract of Aave querying the one from Chainlink. It's fairly simple and I would say straightforward, but again, it generates a lot of cost, because imagine a situation that this contract updates every 15 minutes the price feed, and for 2 hours, because everyone is asleep, let's imagine such a situation, no one interacts with Aave, then the whole updates that were done over here are for waste. And with less popular tokens, because we are not talking only about updating Ethereum price feed, but we can talk about, for example, real world assets. So I don't know, stuff that is not that frequently traded or used. That was the classic model. Okay, and RedStone works in a classic model like this because some users just require such an architecture. And we are not here to tell them it's wrong. We are here to serve our clients, right? And then the second model, that is the true innovation, is, again, here we had Chainlink smart contract, which was updated with the price. Imagine RedStone. RedStone doesn't, the core model, doesn't have this smart contract. So there is no smart contract that is updated. Instead, the data is hit to our data distribution layer, which is an off-chain component. So imagine a layer that is next to blockchain that is off-chain. And to that layer, data providers hit signed data packages. And these signed data packages are available for anyone to pick up as they like. It's like a transparent, open, permissionless off-chain component. And from that component, imagine again, was the smart contract of Aave, and there is a user that wants to do a transaction. Then user sends the transaction via Aave, and before it goes to the smart contract of Aave, on the fly, from our data delivery layer, Aave fetches the signed data package, takes this transaction of a user, attaches it to this transaction. So imagine it's a mail or like a letter, and to that letter you attach this price feed because it goes there anyway. And then it comes to the smart contract of Aave, the transaction is executed, and everyone is happy. So in this second model, this core or on-demand, we don't have this waste of constant updates. Rather, it's delivered on the fly to the transaction only when it's needed. because again, maybe let's recap that. It's not the blockchain that requires data feeds usually. It's the dApp or the user that makes any interaction that needs that, right? So it's a bit of a different approach mentally.
Thank you for walking through that. I think that makes a lot more sense. I want to just briefly mention that gas are basically fees that are paid for executing smart contracts. So whenever you do anything on the blockchain, you have to pay gas. And so one of the things that really comes up frequently in the blockchain space is, okay, how do we reduce the amount of gas that we're burning such that we're not paying a lot of fees? Because obviously the more fees we're paying, the less revenue we're generating. So do you want to explain actually how RedStone Oracles creates profit? Because I imagine there's some, regardless of the fact that this is a little bit more effective or efficient, I assume there's still quite a few fees that are generated.
Right. And so with Chainlink, it's not clear how the business model works. We know that some of the protocols pay them, some are getting fees for free. We know that also some of the layer 1s and layer 2s pay for having Chainlink available on their network. So the business model of an Oracle is not set in stone yet. It's not as easy as layer 1s, because layer 1 is easy. People do transactions and there is a small fee to every transaction. And then that's how you generate the revenue as the startup or organization. In our model, we offer two basic pricing offers for the protocols. So one is a monthly fee. So in this case, Aave or Gearbox or any other protocol can pay us anything between $1,000 to $5,000 a month for having this system operate on their flow. And the final price depends on how much custom work it's required from us. So do they request new tokens frequently? Do they need some support, or they do it by themselves, and so on and so forth. The second option is a revenue share model. So imagine a protocol that for trading on it takes small fee from each trade from the user. And there is, for example, every month a cumulative fee of $100,000. Then we can agree with a protocol that we take a small percentage, let's say, for example, 0.5% or 1% of these fees. And then if there is a month that the protocol generated small amount of fees, it's not a burden for them to pay for an Oracle. But if they created a lot of fees, then we grow kind of together.
That's interesting. I want to take a step back and go back to this off-chain layer, this intermediary layer for a second, and ask you, is there an additional risk that's being taken by including this, layer?
In blockchain, there are always risks. It's rather the question how you assess them and mitigate. So in this flow I presented in the beginning of Chainlinks, there is a risk of these parties that send the data being compromised, or actually in Chainlink, there is a multi-sig. I think it's 7 out of 13. Okay, what's a multi-sig? Multi-sig is a system where for a smart contract or another wallet to do a transaction or an action, at least X number out of some have to agree to do. So you can imagine a multi-sig 1 out of 3. So just one person out of 3 possessors of a smart contract has to agree, and then it's triggered.
Yep.
But you can imagine 2 out of 3, and then 2 people have to agree in order for something to get executed. And in Chainlink, the whole infrastructure is built upon, I think, a multi-sig 7 out of 13. So if 7 people all around the world that have these private keys agree, for example, to switch Chainlink off, the whole system disappears. So this is potentially a risk, right? Because there is someone who can say one day, 7 people collude with each other and say, okay, let's destroy oracles. That's one of the risks. With our case, with this off-chain layer, of course, there are risks of, for example, DDoS, which is an attack where people try to spam a network with a lot of small interactions of low value. But we, of course, protect against that. There could be potentially a risk of malicious player to deliver data to this off-chain component, but we take a signature of every data provider shooting their data to this layer. So if there's going to be something malicious, the end user is not going to accept it because we'll see, okay, it's a signature of a data provider I don't trust, so I'm going to disregard that. And naturally, there are probably some other risks, and there's a bunch of risks that we take into consideration, but yeah.
So for users of the blockchain space, they're going to in some way indirectly rely on oracles. It's very likely at least. So I think it's really important for people to be able to understand some of these risks because blockchain is almost like different layers of risks, especially if you're using infrastructure built on top of existing infrastructure. We recently had Paul, the co-founder of Morpho, which allows people to lend and borrow cryptocurrencies peer-to-peer, allowing them to earn more interest on their collateral. And the thing was that there are smart contract risks within the Morpho protocol, in addition to whatever risks already exist on lending protocols like Aave and Compound. So there's a lot of different risks at play here. And in order to identify these risks, you need to, I would argue, be able to read smart contracts. If it's in the Ethereum ecosystem, you also need to be able to code in Solidity to be able to identify some of these risks. So in your experience, how many people within these ecosystems are actually able to code in Solidity or Rust or a programming language that's required to interact with the blockchain? Is this something that you see as kind of like a future trajectory where more and more people be able to interact with it directly through coding?
I wouldn't say so.
Nope.
I would say it used to be like this. So we used to have bigger user base within crypto that were coders and understanding the code probably. But as we start going more and more into mainstream, the percentage is probably going to decrease over time. So it's very funny that you talked with Paul because I had a call with him like 2 days ago because naturally like we talked with Morpho as well as they are intrigued with our model and how our oracles operate. Hi, Paul, by the way, is a very cool guy, very sharp. In regards to this coding necessity in order to understand the risks, I wouldn't say so. I would say it's more important that the protocol gets enough spotlight and interest from people who are very aware of the protocol and transparently inform the users and people interacting about what kind of risks are for them to assess. Because everyone interacting with a blockchain accepts the risk that it can get compromised or, I don't know, can get like 51% attack when it comes to proof of work or any other type of attack on any blockchain that can be created. So there are always risks, and how I would suggest the listeners to create a mental model is to try to read about opinions of experienced people giving like a review of a protocol or the infrastructure or whatever, because you as a regular user will not be probably capable of identifying all of these risks, or at least understand, let's say, 3 most important ones, because then we can dwell into like very weird risks of, for example, I don't know, AWS, so a cloud service provider going down and disappearing from the world is again a risk, but the probability is very, very low. So I would say a simple mental model, 3 most important risks that you take interacting with a protocol, and then you should also accept them probably if you go that way.
Mm-hmm. I think it can be very challenging though to understand some of these risks conceptually, especially those who don't have any background in computer science. I mean, in like a 51% attack, for example, requires a pretty basic understanding of what blockchain is and how it works. And yet I don't believe that a large percentage of those who interact with the blockchain, as it should be, most people don't really understand how the internet works, including myself. So, I think there's, it can be a little bit of a challenge, I think, in the blockchain space, given it's only been, 14 years now, a very short period of time within the industry. Okay, let's go back into RedStone Oracles for a moment. I want to talk about front running. So front running is a topic that's really important when it comes to oracles because it can do a lot of damage if it's not addressed properly. So do you want to explain what front running is and then how RedStone Oracles attacks this problem?
Sure. So front running is a problem on blockchain that is not present on traditional finance, to the best of my knowledge. And it's possible because there is, how execution of a transaction happens, let's say on Ethereum or other blockchain, is that when you hit, let's say, sign a transaction and send it, first this transaction goes to mempool before going executed, and then block producers can pick the transaction and then execute it on the block. So there is a period between the execution and visibility of the action, during which some actors that monitor these transactions that are about to be executed can manipulate the order of the transaction and then try to extract value out of it.
Mm-hmm. I'll just jump in here and just provide a little bit of context before we go a little bit further, because there's really a lot here to unpack. Okay, blocks are added to the blockchain. The blockchain itself is made up of transactions. The order of the transactions within the block can be manipulated by miners or whoever is responsible for validating the blocks. And on top of that, right, this time between when the transaction occurs is actually added to the blockchain. That's when it goes to this thing called the mempool, and that's when people are able to rearrange the transactions. And there's really important to note that basically when which a transaction occurs is very important. Whether it's one after the other or the one before. So we have the mempool, we have blocks, and blocks being added to the blockchain, transactions within those blocks.
Yes, and then front running means that when you monitor these transactions that are already visible but not executed yet, you are also aware of the price upon which these transactions are going to be executed, because the price is stored on the blockchain. So in this Chainlink model, they are visible to everyone. So you can easily calculate how to try extract value of the order of these transactions, right? Whereas, for example, with the third model that I haven't talked yet from RedStone, which is called Model X, which is front-running protection model that we co-created with GMX, the flow is a bit different. And now bear with me. If you are using a perpetual protocol that uses RedStone X, first you create an order. For example, you want to create a short position on a specific asset. Then that order goes to a dApp. The dApp will send it to the blockchain in block N, so the next block, but will not be executed. It's just going to be visible. And then the price upon which this order is going to be executed is not visible to anyone, because the price is not on the blockchain. It's rather in this data distribution layer. And from that layer, anyone can pick the price, can pick the order that has been submitted to the blockchain, connect the two, send it back to the protocol, so let's say GMX, and then that transaction is executed only in the very next block, so let's say block N+1. In that sense, there is a small delay between the order of the between the order and the execution. But on high performance chains, it can be 0.3 seconds or maybe a second. So it's not that the user doesn't feel it that much. But thanks to that, there is no, like, the people see the order that will be submitted, but they don't know the price. So they are not capable of extracting the value because they cannot calculate how to make it profitable.
Wow. Yeah, a lot to unpack. A lot of the blockchain, I find, is, or at least the space, is a lot of new terminology, new ideas. Okay, let's talk about some of the potential that RedStone Oracles has to, I'd say, revolutionize the quote Oracle space in blockchain. So what have been the implementations of RedStone Oracles? How many dApps have you guys been incorporated so far?
Yeah, so as I mentioned, right now we have 14 dApps, like the serious dApps that are using us. Of course, there are way more on testnet or hackathons and so on, but let's calculate the serious players that already protect, play with real money and hundreds, thousands and millions of dollars. And when it comes to some notable apps that use us, for example, one is called Delta Prime. The Delta Prime protocol creates decentralized prime brokerage accounts for every user, so that you can take, watch out, under collateralized loans, so that you can create even higher leverage for your positions. So it's again a very specialized DeFi application. Another application that uses us is called Mento protocol, which is the biggest protocol on the Celo blockchain that creates a stable coins. One is CUSD, C Euro, and also C Real, which try to emulate the value of these currencies, corresponding currencies, right? Another protocol that integrates us as we speak is called Gearbox, which is again a protocol for leverage. So I would say one correlation that we see is protocols that require lower latency and also some more sophisticated infrastructure than simple lending usually find Redstone very attractive. And another vector are ecosystems that Chainlink is not present at. So for example, Linea, layer 2 from Consensus, ZK Sync Era, Polygon, ZK EVM, and so on and so forth.
Okay, so let's jump into Arweave and Streamer for a moment, because I know it's a very important building block when it comes to RedStone Oracles and how it's functioning. So do you want to explain how these two pieces are incorporated into the puzzle of RedStone Oracles?
Of course. So as I mentioned, Redstone, one of the core infrastructure plays in Redstone is this data distribution layer, which is an off-chain component, and it consists out of multiple services. One of the services is called Streamer Network, which allows for signed data packages to live in this off-chain component and be available for anyone to pick up. If anyone has ever used cloud services from the listeners, there is a service called PubSub, which listens to events and then triggers an action upon that. Streamer is a kind of like a decentralized PubSub. And Arweave in this data distribution layer is used for storing data permanently. So what Arweave chain offers is an affordable storage of data for at least 200 years, which can be in current technical conditions called permanent. And every data package that is utilized from Redstone is also stored on Arweave, so that whenever there's a problem or someone would like to retrieve historical data, can easily go there and pick it up. So both of these services are very interesting. I would say Arweave is a total game changer when it comes to thinking about storage. So I highly encourage everyone to read more about both of them.
And when you chose to implement Arweave, were there other competitors that you were considering also? Is there like a distinctive thing to Arweave that makes it different from competitors?
Yes, there are a couple, but I would focus on two major ones. One is the payment process. So with Arweave, you pay once and then you don't have to care about that. So you don't have to have like a service that keeps on paying like a monthly fee or even yearly fee. You paid once and then you can forget about that, which is way easier operationally when you create a service on top of it. And then second thing is Arweave stores data for a very long period. Let's call 200 years. It's such a long period that doesn't matter for a single, let's say, person lifespan, at least for now. Whereas with competitive services, usually the storage after 3-4 years start becoming questionable. So to give you an example, we did explore Filecoin as well and IPFS. And the biggest these two issues were, that's what we found. One, we would have to create additional service to keep paying for storing the data. And then the second is, after approximately 3-4 years, the incentive for nodes to keep the data longer starts becoming less and less obvious. Sure. So you can end up, for example, paying 5-7 years. And then when you check the availability of the data for the node operator, it would be better, for example, to delete the data and pay the fine instead of keeping the data and then giving it back to you. So sure. I would say these are the main considerations there.
Interesting. The last question for today is I'd love to learn a little bit more about what's next for RedStone Oracles. So what's lined up for the roadmap?
Oh, there is a lot to unpack there, but I would say the major thing that we focus as for right now is integrations of new protocols. So every single day we have a couple of conversations with protocols from various ecosystems, trying to, one, understand how Redstone works, and two, how it can create additional value for the protocol that is already running or can be implemented in the next version. Because in blockchain space, many times protocols have many versions. So for example, there is a release of V1 or version 1, then after half a year is a release of V2 version 2, and so on and so forth. And usually in between the versions, you can do some major tweaks to the infrastructure that you're using. So many times when someone created, for example, V1 or V2 and is working on another version, then they ask us, hey, how we can make another version even more efficient with your system. So this is for sure one that we focus at. The second one is expansion to new ecosystems that are prominent. As we speak today, Base already have mainnet, and Redstone is available there for users to integrate for the protocols. We're available on Mantle, Linea, ZK Sync Era, Polygon, ZK EVM, Caldera, which is a rollup as a service protocol. So people can easily spin up their own rollups without having that much of technical knowledge and also capabilities. And then when they spin a rollup, usually they need an oracle. So it comes in a package with Redstone, right? So you don't have to think about every single piece of a rollup. You just get it as a whole when you create a new one. So I would say expansion in that kind of areas is very important. Last but not least, keep being very close to the ecosystem. So we go to many conferences. Lined up, we have ETH Warsaw in Warsaw, Poland. Later, we go to Masari Mainnet in New York City. We are going to be present at Dev Connect in Istanbul and probably a couple of other conferences such as DAppCon in Berlin. So one of the things that we will keep doing is being very close with the developers and builders so that there is a very short feedback loop of their needs and the innovation cycle. Because one thing that I want to remind people that are listening, the podcast as we create today, probably in half a year, will be a bit obsolete. The reason for that is the innovation cycle in Web3 is probably like 3 months. So there is constantly something new popping out that you have to pay attention to. So I would say, yeah, that's the plan for Redstone for now.
Great. And another great reason for you to join me on the podcast half a year from now to see what the updates are for the protocol or for the Oracle.
Yeah, I suppose after half a year is going to be one of the most listened podcasts in Web3. And I'm very happy to, rejoin you again.
Excellent. Okay. Marcin, thanks so much for joining me on the podcast today. It was wonderful having the opportunity to learn more about RedStone Oracles. I'm very excited to see how it continues to succeed in the upcoming future.
Thanks a lot for having me. And see every of the listeners on many of the events. I welcome every of you in ETH Warsaw. That's my home city. So it would be excellent to catch up with you over here. Thank you.
Thank you for listening to this episode of the REKIM podcast. Please consider supporting it through the Make a Contribution button or the wallet address found in the video's description.